what do we have here? Okay, this is section 3.3 in college algebra, and we're going to concentrate on how you graph a polynomial function. The key things are what's going to happen on the end of your polynomial. Does it rise right, fall right, rise left, fall left? What are the zeros? Where does it cross the x-axis, and what is the y-intercept? Let's start with the easiest thing, the y-intercept. Everybody knows the y-intercept is when x equals 0. So f of 0 here, all the parts here would be 0. 0 minus 0 minus 0 plus 25 times 0. F of 0 equals negative 12. And if you look, 0, negative, here's negative 10. So the y-intercept is going to be somewhere down here. The zeros would be the most exciting thing. But before we do that, let's look at, we have f of x equals x to the 4th power. And that's even. So what we know about even functions is they rise on the left and on the right. So now we need some zeros wherever the graph is going to cross the x-axis. Luckily they tell you, given that 1 and 3 are zeros, so you've got a 0 at 1 and a 0 at 3. So what we do with that is we use our friend synthetic division, and we plug in 1 and 3, and we'll get this down from x to the 4th to x to the 3rd, then down to x squared, to something we can factor to find our last two zeros. So we have 1x to the 4th minus 1x to the 3rd minus 13x squared plus 25x minus 12. And it tells us 1 is a 0. So we do synthetic division. We bring the 1 down. 1 times 1 is 1. We add 0. 1 times 0 is 0. Add negative 13. 1 times negative 13 is positive 12. 1 times positive 12 is 12. We get 0. Okay? That's the first 0. The second 0 is the 3, so we put a 3 here. We bring the 1 down. 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 13 plus 9 is negative 4. 3 times negative 4 is negative 12. 0. So we have x squared plus 3x minus 4 equals 0 is what's left after we plug in the two zeros. So we can simply factor this, and we see it's x and x. Got negative here with a positive in the middle, so we must have one positive and one negative. What two numbers multiply to 4 and add to 3? So negative 4, positive 1. This will give us the negative 4, but it'll give us a negative 3 in the middle, so we change this to here and negative 1. So this is x minus 1 times x plus 4 equals 0. So your other two zeros are at x equals 1, x equals negative 4. So put a point at negative 4, and there is a 0 at 1. Okay? So now we'll talk about something called multiplicity. We saw this, I believe, in section 3.2, the previous section, but it's been quite a while. So we have an even function. We know it rises to the right. And at 3, the multiplicity of 3 is just 1. 3 is only a 0 one time, so it's going to go through. Now, we don't, in all honesty, we don't know how far down it goes. Maybe it goes way down, maybe it doesn't. But we know it has to go to here. And at 1, if you look, 1 is a 0, but it's also a 0. It's a 0 twice. So what happens with that's called a multiplicity of 2. If you have an even multiplicity, when you come to that 0, instead of going through, it turns around. Goes back over here to the y-intercept, and then it's going to have to go back up and through here. So your graph rises to the right and to the left because it's even. You've got 1, 2, 3 zeros. It's kind of an ugly looking graph, but basically we know for sure it rises on both sides. Here are zeros, and we're not sure how much it goes down here. It comes down through here to the y-intercept, and it may turn around there. It may go a little lower, but it has to go back up through this last 0. Let's try the same thing over here. It says given that 1 and negative 3 are 0. So we have negative 1 for negative 1x to the 4th, negative 6, negative 8, positive 6, and positive 9. Now this is negative x to the fourth, so it is going to, the end behavior tells us this is going to fall on the right and the left. Now if this degree is odd, it does the opposite things, but since it's even, it does the same thing both on the left and right, and since it's negative out front, it's going to fall on the right and fall on the left. So we're given that 1 is a 0, so let's do our first synthetic division. When synthetic division, you bring the first term down, and you multiply 1 times negative 1 is negative 1. Add, you get negative 7. 1 times negative 7 is negative 7. Add together, you get negative 15. This looks ugly. What's going to happen? We're going to get a 0 here. Watch the magic. 1 times negative 15 is negative 15. Add, you get negative 9. 1 times negative 9 is negative 9. You get a 0. Hooray! Okay, let's put in our next 0, which is negative 3. Bring the negative 1 down. Negative 1 times negative 3, positive 3, negative 4 when you add. Negative 3 times negative 4 is 12. Minus 3, watch this magic. Negative 3 times negative 3, positive 9, remainder 0. So now what you have, it was a fourth power, and you put this in, it becomes a third power. Put this in, it becomes a second degree. Second degree is probably a better way to say it. Minus x squared minus 4x minus 3 equals 0. You could divide through by negative 1, which is advisable. X squared plus 4x plus 3 equals 0. All I did was multiply both sides by negative 1. 0 times negative 1 is 0. Multiply negative 1 times all these becomes positive. Much easier to factor. It's nicer looking. So this factors. Everything's positive, so it couldn't be much easier. It must have all positives. And 3 is prime, so it's 3 times 1. So your zeros are x equals negative 3, x equals negative 1. And we've got a 0 of 1 and negative 3. So negative 3 twice. That one's going to be interesting. So 1 0 is at 1. 1's at negative 3. That has a multiplicity of 2. So wherever we touch that, it's going to hit this point and go back around. The other 0 is at negative 1, which has a multiplicity of 1. Now we know the graph falls right and falls left, so it has to fall here, fall here. This is where we try to find the y-intercept. Y-intercept, x equals 0. So we got 0, 0, 0, 0, 9. So there's 0, 9. So the graph goes up to 0, 9. That's really ugly. It's really a lot smoother than that. I apologize about that, but somewhere it turns around and it goes down here to negative 1. Now, negative 1 has a multiplicity of 1, so it comes through. Which one had the multiplicity? Yes. So it comes through, and when it comes over to negative 3, we know it has to make a turn here because it has to go up to this other 0. But negative 3 happens once, happens twice. So what that does is it touches and turns around, even multiplicity. And there you have the graph.